Trigonometry, Chapter 7, Applications of Trigonometry Vectors. Section 1, Oblique Triangles and the Law of Sines. Video 10, The Law of Sines Ambiguous Case Example 3. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we solved an SSA law of sines problem that had two solutions. And the one before that, we solved one that had no solutions. In this video, we solved one more SSA law of sine problems. A spoiler alert, this one will have one solution. For example, in triangle DEF, suppose angle D equals 70.0 degrees, side D equals 14.5, and side E equals 13.1. Solve the triangle. Now, we could check for the number of solutions up front. And since D is greater than E, this should have one solution. But again, if the change of variables from A, B, and C to D, E, and F makes it difficult for you to determine in advance how many solutions to expect, skip it and just solve the problem. The number of solutions will rectify itself if you know where to look. So let's start by using the law of sines to find angle E, which makes sense. We know the complete angle side pair for D. We know half of the angle side pair for E. Sine of D over D equals sine of E over E. Sine of 70 degrees over 14.5 equals sine of E over 13.1. If we solve this for E, we would multiply by 13.1 and take inverse sine. So we would get E as sine inverse of 13.1 times sine of 70 degrees over 14.5. And if you carefully put this into a calculator, you should get 58.1 degrees. But remember, when you use inverse sine to find an angle with the law of sines, you must consider the supplement. So our first value of E is 58.1 degrees, and our second value of E is its supplement, which is 121.9 degrees. And by the way, at this juncture, you can determine that we're only going to get one solution. Do you see why? If not, don't worry, we'll get there. So let's start with solution number 1, where angle E was 58.1 degrees, the value that our calculator gave us using sine inverse. Then we can find the remaining angle F by simply subtracting the two known angles from 180 degrees. That would give us 51.9 degrees. And now we're going to find the missing side, which is F. So we're going to use angle F, sine of 51.9 degrees over side F. And let's use the given angle side pair of D's. So sine of 70 degrees over 14.5. And if we solve that for F, we can cross multiply, divide to get the F by itself. We'll get 14.5 sine of 51.9 degrees over sine of 70.0 degrees, which is approximately 12.1. So our first solution is, remember, we were given angle D, side D, and side E. Angle E is 58.1 degrees. Angle F is 51.9 degrees. Side F is 12.1. Notice that the longest side is opposite the largest angle, etc. The longest side is 14.5. The largest angle is 70.0. The shortest side is 12.1. The smallest angle is 51.9. The middle side is 13.1. The middle angle is 58.1. Always good idea to spot check that, because if something went wrong, it might show up here. And go back and fix it. All right, so let's go to the second solution, where our angle was not 58.1 degrees, but its supplement 121.9 degrees. Well, we know two angles. Let's find the third. Angle F, second version, is 180 minus the other two angles, which is negative 11.9 degrees. Theoretically, that's an angle, but it can't live inside of a triangle. So in the case where only one solution exists, this is where it falls apart. The second possible angle, which in this case was 121.9 degrees, is too large to fit in a triangle with the given angle, which in this case was 70 degrees. In this specific case, the second angle for E, 121.9 degrees, is too large to be in a triangle with D equals 70 degrees, since the sum of those two angles already exceeds 180 degrees. So going back here, when we first found our two angles, Let's quickly summarize the things that can happen when you use inverse sine in the law of sines. When you get to the inverse sine, number one, your calculator says domain error, which means no solutions. Otherwise, you get an angle and must consider its complement. Now, at this point, when you consider its complement, the acute one will always work, assuming that you get one, assuming a solution exists. The acute angle that your calculator gives you will always work. But when you find the supplement, if you just want to quickly look at it and the given angle and go, wait a minute, those are more than 180, you can instantly throw it away right there, or you can catch it later. So inverse sine doesn't exist, no solutions. Otherwise, use an angle and its supplement. But if that supplement is too big, don't use it. Or just figure it out over here. So we only had one solution. So the takeaway is this. When you're using the law of sines to solve a triangle, and you have to use inverse sine to find an angle, be aware of two things. It should actually say three things. So we're going to fix this. Fixed. When you're using the law of sines to solve a triangle and you have to use inverse sine to find angle, be aware of three things. Number one, if you get a domain error, there is no such triangle, assuming the work leading up to it was correct. Number two, otherwise you get an angle, but don't forget to calculate the supplementary angle as well. So you have two possible angles to consider. But if that supplementary angle is too big, meaning when you combine it with the original given angle, it exceeds 180 degrees, discard it. Otherwise, you find its solution as well. So this replaces that list of if this happens, no solutions. If this happens, one. If this happens, two. If this happens, one. Just solve the problem. And remember, when you're using inverse sine, domain error means no solutions. Otherwise, you get an angle. Don't forget to calculate its supplement. But if the supplement's too big, throw it away. And then you chase down each solution. Now you try. Pause the video and try the following. Solve triangle ABC. If side A is 180, side B is 80, and angle A equals 180. Excuse me. Angle A equals 100 degrees. All right, if you haven't paused the video yet, this is your fair warning. Solution in 3, 2, and 1. First, set up the law of sines. Sine of 100 degrees over 120 equals sine of B over 80. We get angle B1 equals sine inverse of 80, sine of 100 degrees over 120, which is about 41 degrees, and angle B2 would be its supplement, which is 139 degrees, which is clearly going to be too big, but let's chase it down. Solution number one, angle B is 41.0 degrees, angle C is 180 minus the two angles to give 39.0 degrees. Then we set up the law of sines to find side C, and get side C is about 76.7. But on solution 2, if we use angle B equals 139.2 degrees, it's too large to be in a triangle with a 100-degree angle. Their sum exceeds 180.